Alright guys, in this video we're going to be looking at some representations of reactions through a particulate diagram. And this one's a short answer question, so I'll be drawing in the diagram itself, shown in these like beakers, and basically we're drawing what the ions and atoms look like. After preparing the solution, the student places some of the solution into a beaker and adds a sample of aluminum. The reaction represented by the following equation occurs. So we have 1 aluminum plus 3 Ag silver ions will go and it will form 1 aluminum ion and 3 silver ions in the solid state. So a big thing is we're going from solid aluminum to aqueous aluminum, and 3 silver ions turn into 3 solid silver. So it's a 1 to 3 ratio in that aspect. We are asked to draw the end result of this reaction, and we want to include the correct type and number of particles based on shown on the left, and the relative spacing to depict appropriate phases. So number 1 is just making sure I have the same number of atoms on the left and the right, and that they're in the correct, so number 1 just says you have the correct amount on each side. On this second part, it wants us to make sure we have appropriate spacing for the phases. Solids should be at the bottom, and liquids should be somewhere near the bottom, and gases it's floating in a liquid, so then all these ions should be above it. Okay, so looking at this one, we are going from 4 aluminums in the solid state to 2 aluminums in the solid state here, which means 2 aluminums have turned into ions. So I'll make sure I put 2 aluminums that are now ions. And I'm going to put them floating in the air, it's floating in the liquid, so it's going to be floating around to make it look like it's an ion. So when those 2 turn into ions, because we lost 2 and turned in the solid state, that means for every one of these aluminums that turned into an ion, 3 silver ions turned into the solid state. We can see that in this reaction here, right? For every 1 aluminum, we would get 3 silver in the solid state. See how we got that? So on my bottom here, I want to include 6 silver solid atoms. So 1, 2, 3, 4, 5, 6. I'm just going to put them on the bottom. I would label them all Ag, and it's really tough on my iPad, but you kind of get the sense or understand what I'm trying to do here. These are all silver solid atoms. Okay, now on this left side, I had a total of 8 silver ions over here. So there's 1, 2, 3, 4, 5, 6, 7, 8. If 6 of them turned into aluminum or silver solid atoms, that means 2 more of them would be in the ion phase. So this would get full credit because of the 2 things that I did. First off, I have the correct number of atoms on each side. I had 4 aluminums on the left, 4 aluminums on the right, 8 silver on the left, 8 silver on the right, and then I get another point because I put everything in the correct area. Solids go to the bottom, ions are floating in the top. So as long as you keep those pretty much in order, you're making sure you're putting the atoms in the correct spot, you're labeling them, and you have the correct amount on each side, you should get really easy points for questions like this.